Okay, welcome to another of our class. This is class 12, right? And today we are going to do like hands-on practical design on the sewage or drainage, waste and vent system for buildings. So we already did one last class, so I'll need to go back to it for a couple of reasons, right? But before we go into it, I would like to talk about hot water sizing, right? So this is what I'm looking for. Okay. Hmm. Okay, so in sizing water heaters, right? After you finish sizing it with this our template here, right? So this is how this is for tankless, where you indicate the GPM, like simultaneously required GPM, and then the elevation of the highest fixture in that building and all of that, right? So you see that the key items or the key values here are GPM and the kilowatt rating. Like I said before, I generally prefer to choose tank water heater because they usually um they usually have like low energy consumption, and that results in lower energy bills, right? So you can see that this is a tank water heater and tankless, right? And this is 82 GPH, which is not very far from this if you convert it, right? But you see that this is 7 times the energy required than this, right? For the same energy rise, temperature rise, right? So this is why I prefer to use this in a lot of cases, but that is not set in stone, right? If for any reason, either on request or you see that it is more suitable to use this, feel free to use it. I mean, right? I mean, it's usually very efficient, right? So as I was saying, so now the main factors you use is just to get the amount of the flow rate that is needed, the maximum flow rate that is usually needed, which is this. And this is because we don't want to undersize, right? If you undersize the water heater, you will not be able to meet up the demand, right? And I mean, I've showed you how to do all of that. So in this case, this is it, right? The demand, the maximum demand at a time, right? And this is also the amount of energy required to heat it. Now, this is less than for tankless or instantaneous because it it doesn't need to heat it very fast. This is so high. This is so high because the amount of energy required is rapid, very fast, because it's needed instantly, right? But for this one, it hits at a slower rate. As far as the gallons or the volume of the water heater can still sustain this um um rate is fine, right? But then again, these gallons is still not set in stone because sometimes you may need something that can set this. This is just like a minimum size, right? So it can always be larger, right? Um, so once you get this, you just have to search for something that can handle in order priority this energy, this energy or power. Wattage is power, yes, right? And I'll just call it energy because that's the electrical power needed to heat it, right? Then if it's for a gas water heater, that one is usually measured in BTU, right? British thermal units, right? It's still energy, amount of energy required to heat the water. So you get your GPH, you get your total after your adjustment factor and your height, and then you get this finally, right? So so now after doing that, you can just go to some standard or some reputable water heater companies. This is one of them, American Water Heaters, and you can just check through their their specification sheets, right? So as you see, this one is for commercial electric, right? You see, this is key kilowatt input needed. This for electric water heaters. So you check here, you see that for this one is way less. Is mostly this is the highest, 6 kilowatts. And what you are looking at here was about um tank was about is about 10, right? So either we take two of that, or we just go higher and see if we can find something that can take even more. So this is still, I mean, it's based on the elements, right? That's why it's modular, it's one by one, right? So maybe the minimum size is 4. Okay, these are the minimum sizes, right? And then it's in multiples of this, right? So you can select maybe something higher so that this model now has options of 4.45 to 45. Yeah, some options, some models have like a range too. So there's a minimum and there's a maximum depending on what the demand. These are mostly small water heaters. So if you go further, you can see other information, right? And this one, I think, is a max of 6,000. But anyways, just search for the specification sheet for the water heaters. This is another one. This is Rheem water heater, right? Yes, this is Rheem water heater. So it will give you some information about how they are, and then you just look for the that kilowatts. This can handle higher, and this is tankless, right? Most time tankless usually have higher kilowatt compared to tank water heater, right? Because like I said, is needed instantly, rapidly. So this one I can help you select. Now they also have like a rule by thumb of the GPM needed per fixture, right? Whether you decide to use this or the one in IPC is by your discretion, right? So I'm not going to tell you whether or not to use it. Most of these things are estimates, so it's just better to choose the better estimate for your project, right? So let's see if you have any other thing. Okay, that is pretty much it. So just go to other popular, just look for either popular or easily available water heater companies within that state or that country, and then you can just go to their specification sheet and just get what you want, right? So now let's get back into this, right? Designing the um drainage system for this same residential building we've been working on in the past. So let's go on. Okay, another thing I talked about. Okay, yes. Before we go on, let's size. I didn't add clean outs and show you the riser diagram for the last video, the last building we worked on, that coffee shop. So let's do that real quick. Okay, I'm not sure I talked about. Okay, I mentioned this how this venting was done. I'm not sure I talked about this called clean out, right? So I mentioned how clean out is important in buildings for um I mentioned how it's important in buildings for maintenance and maybe easy access into the plumbing line in case there's like a blockage or you need to like service it, right? It is always placed at the entrance or the exit, the final exit, and it's also placed at like places, areas of um sharp changes, like this is a change, right? But it's also important to place in such a way that it doesn't interfere with the flow. This now flows in this direction, right? So this is placed here, so it's not going to like interfere with it. So another thing to consider is that it shouldn't be placed in a place that's not accessible, right? So for example, in a wall, if for example this change happens within a wall, it is not advisable to place it. Let's see. Okay, clean out. Okay, these were something that talk about clean out, right? So at change of directions and at every 100 feet, if it's like a straight run, right? And then at the base of stacks too. Stacks is just the vent matters and other types of stacks too, right? So after that, let's talk about the venting, the riser diagram of this particular project, right? So okay, as I've said before, the riser diagram is just like a schematic of what your layout looks like, right? A brief schematic, right? So that when somebody looks at it, they have like a clear picture of what it is. So did we use a septic tank? I don't think we did. We went to sewer, not septic tank. Okay, we used a septic tank, right? Okay, so we use a septic tank, which I did not size. I will size that today, right? Septic tank and with the main line, right, of this size. And I say this is because there's at least a WC, right? A WC has like a size of 3 inches, right? So now, remember those floor drains we spoke about? So these are the first to enter into the system, and then we have this. This is like the primary, exit, and secondary, right? Because there's like a branch of, it doesn't flow directly. It flows through the system, right? So this is the primary exit, and then we have the secondary. This is like the secondary exit, and secondary. So now, remember those floor drains we spoke about? So these are the first to enter into the system, and then we have this. This is like the primary, exit, and secondary, right? Because there's like a branch of, it doesn't flow directly. it flows into the line of the sink, and then before it goes out into the main line, right? Now the venting, remember that the venting, we had just 2 points into the roof, right? Venting to the roof, which is indicated by this keynote here. So, and then I usually like to put this where there is closest, as close to the water closest as possible, right? So that's why as this went straight here, I just put it here, right? Because this is the um highest source of smells, right, in among the two of them. So I mean, it's just a coincidence that they are in the same, they arrived at the same junction, right? So there's a vent line that comes up here, right? Okay, let's indicate that here. So there's a vent line. Okay. So let's go to our vent layer, right? So so this basically just goes here. In many cases, I always like to, or it's usually advisable to ensure that your sewage line passes into a wall, right? Preferably the back wall of that space. But in this case, I did this because this basically comes out into the ground, right? In some models, it goes into the wall, right? So that is another alternative. But I just imagine going out like this around, and it just did not sit very comfortably with me. That's why I choose this, right? So now this goes here, and along that drainage line, there has to be a vent in a wall. That's why it must always enter into a wall, right? So you can see here that for that WC, this is it. So that vent now is where the, actually this, to be honest, this shouldn't be here because I didn't vent it immediately. It was around the point it met here, right? So let's edit that real quick, right? Right. But I mean, that basically just talks about how it works, right? So yes, then it also collects from. So also observe how this is the final. It there seems to have been a mistake somewhere, right? Because this is the exit point. So what is exiting first is this WC and sink and lavatory rather, not the floor drain. So that's a mistake on my part, right? So these should be first, closest to this before this. So that's a mistake on my part, right? So let's quickly make that change before we proceed. Okay, so somewhere here, and then move this. Okay, yes. Okay, escape, move this. Now you're wondering how I'm able to edit on this page, on this sheet page, is because I was able to toggle this. So from paper to model, right? So if it is on model, when I press paper, it means I can edit what is behind. Right, can move this somewhere here. Okay. Okay. This it works now, and then I extend this. I'm careful, I don't want to move this around too much because if I do that, it's going to, I will need to have to rearrange it on this page. So now let's go back to model. And when I like zoom back out, it's now fixed. It's not moving anymore. So that's just pretty much what it looks like, right? So you're still on the vent line, right? Usually I like to vent the WC as I mentioned. So I'm not very comfortable that I removed this vent line because, okay, right, let's just leave it as it is, right? Because they both meet here eventually. So this is still venting off this line, basically, right? Okay, let's do this. Let's do this. Because usually the priority when it comes to venting is the WC, right? So now this means now that I'm no longer venting this directly. This now means I'm venting directly. Okay, I need it somewhere here. I'm venting around the point where it meets, right? So if I come here, okay, so I'll extend this down here. Okay, now this, even though it doesn't make much difference, but I like when it just meets what I want. Then if you see this one now, there are two vent lines that go off from the floor drain and then they meet up here, right? So let me save that and show you how that worked here. So you see this broken line of seeing here, just where the vent line is traveling in within the wall, vertically within the wall, and then they meet somewhere horizontally at some height in that wall. And then you have the exit point, which is at this point, somewhere around the middle, as you can see here. Right. So now let's go back to our task for the day. So let's design the drainage system for this building. Right. So this building, we are going to be using a sewage line, sorry, a septic tank also, which I'm going to size. Okay, I've seen that there's a problem here. I copied this from one of my former drawings and this entered because I grouped it together mistakenly. So I'm going to remove it now. And how to do that, I'll ungroup. And yes, now everything is separate and I can select, yeah, select and delete this. So I can group back. The reason why I like to group is so that I won't have to be, as I'm drawing my lines, I don't have to be interfering with all these little small lines, right? So let it be one whole thing so that if I want to deselect or select everything at a time, it's easier, right? I just need to select one part of it and then the whole thing selects like this, right? So moving on, let's draw, right? So now let's go to my sewage line, which I'm already on, and then I'm going to draw a line. So these are, we've already talked about how, oh, there seems to be, okay, okay. That just means to snap to a particular point, right? Okay, so this is a wall, like I said, going into the wall behind. The only times you go into another type of maybe a wall that is not behind is maybe if it's just difficult to align it, because this is where the technical aspect comes in, right? Where you have to plan the best route without compromising the design, because the design should look good, right? Because the best designs are the ones that are both technically correct and also appear good to the eyes and are also easy for the contractor or the person on site to do, right? So let's just pause there. I would like this to pass within this wall, right? Because this is the kitchen space, and like I think I mentioned sometime very early in this course that uh, routing drainage lines is very, you have to be careful, or you have to be specific about not passing like some eating or living areas. Avoid them as much as you can, right? I mean, odds of leakage is very low, but if it should happen, let it happen in spaces that if the owner of the house or the building is there, it's not going to inconvenience them too much. So I want to move this up, that is out of that kitchen space. I mean, right now it's going to be within this wall in case of anything. I mean, this increases the difficulty when it comes to maintenance, but we'll take that. Right? So I mean, this looks like a clean out, but you can't be a clean out because this is the flow of this, and then it's going to come and get stuck here. So we'll take this out, right? Don't worry, we'll put a clean out somewhere, right? So now what are we venting? What are we draining again? Okay, the WC, right? So that goes from here, just like this one here, from here out straight, and then it bends. Remember our 45 degrees. Okay, this 45 degrees. We always could clean that up, right? Then this. Now I would have wanted this to enter into this wall behind, but it's just going to be very messy to connect into this. So I'll take it to the front instead. Luckily, this is just is on the floor, so it's just going to drop into the floor and then out into this wall. Why I need to go to a wall is because that's where we're going to do the venting, right? So it goes straight into this wall somewhere here, and then that 45 degrees, very very necessary. Okay. Okay. Yes, I'm to lengthen this a little. Okay, and then that is trim. Okay, extend it then trim here. Okay. So what else? What else is supposed to? Okay, this is a washing machine. So perfect. So this line is underground under the slab, right? So it passes directly under that, and that is why I selected it to pass here. Passes directly under here. So I'm just going to make it so that this is just going to drop directly into it, so it doesn't need to. So if it's entry, it doesn't need to enter a wall because this is already connected to a wall. So I'll just vent it at this point at once. Alright, which other thing do we have on site that needs drainage? Okay, here. So what I did here before, I'll do it here again. Right. So take from here, 45 degrees. Come here. Right, then join here. No, that's a mistake. Control Z. So it needs to join at 45 degrees. That one is non-negotiable. Okay, this is tight 45 degrees, right? Then this one now is going to be too tight for it to go out, right? Like this. I'm going to take it from here. So something like this. 45 degrees. Okay. Right. I mean, it could have gone straight, but this is still fine. Right. What else? Okay, this is a bathtub. So this one now, I'm going to take it from here. Okay. Into this line. Into somewhere here. Okay, let's use 45. Okay. Okay. Then this is the kitchen sink. So how do we do this? Let's go like this. So it goes straight. I mean, I could have passed this behind here, but let's just do this first and we'll look at it again. Now I want these two to meet at this point because if there are two of them, it's going to be in two different fittings. So I want to help the guy by just putting one fit. I mean, the person on site physically would choose which one works best for him, right? He can decide to separate them, or he can decide to oh, that's a mistake, or you can decide to do them together, right? So this is from here. So I want them to meet here so I can just vent two of them at once. And thankfully, things like bathtub and sink, they don't usually have very high requirements when it comes to venting. Like WC is usually something that you pay like a lot of attention to, right? Oh, do you know that I forgot to make this all green? That's something I always do. But I mean, let's just leave it as this so that we can see the different fixtures, right? I usually make it all green so that the colors don't intervene. Like this now is just a bit distracting, right? So let's just continue like that. So this will be my exit point. Now let me add my clean out. I mean, I'm done at any point, but let's just do it. I mean, the earlier the better, so I don't have to procrastinate and then I'll forget like before. So there's a clean out here because the flow goes like this. So now this is outside the building, so it's not a problem, and it's at a change of direction, right? This is another change of direction, so I'm going to add it out here. Now if you notice, this would have been a problem if it ended inside this wall, but I mean, you can always extend to the garage, right? Good. So I mean, if for any reason there's need to like do maintenance on these lines, it's easy to access it from this piece, right? Okay. I mean, if there was don't worry, we'll see such. If you come across such, I'll just mention it. I'll just refer back to it, right? So I'm going to be using a septic tank in this, right? So add another line. Okay, 45 and this. So while they clean out here, and then our septic, why I put it there, because the client told me that the septic tank is somewhere here, right? So let's leave that first, come back to it. So what else do we do? I think we had a checklist. So this is our checklist, right? So identify fixtures, we've done that. Okay, we've not assigned DFUs. Let's do that real quick. DFUs is just values to show. I mean, okay. Let's complete this layout first, right? And to complete that, we're just going to add this. Okay, so this is what it looks like after, right? So now this is just showing where the drainage line collects, where it meets the fixture, and this is to indicate a strainer, and that strainer is usually used in fixtures that should not allow solid waste to pass through, right? So that's what this basically means. It has something like a gauze, right? But in WCs let solid waste pass through it. So in this case, you see that I didn't add that. And also, this usually goes with smaller pipes. I mean, hence why solid waste shouldn't be allowed to pass, right? So then this is our vent. This is just indicates a vent pipe that is vertical going up, right? And then this indicates where this is the vent stack, where the pipe penetrates the roof and goes out to the open air, right? This one doesn't penetrate the roof, it's just up within the wall, and then it connects to this one, right? And then this is our cut clean out, and this is another strainer. And if you notice, there always this size 2, which I've explained before, but we'll look at it again, right? This one is basically another point where it hits, and if you notice, all these are usually along the walls, right? That is why it's necessary to extend your pipe into the wall, right, so that it's easier to vent, right? And then this is another clean out. Okay. Now this is looking a bit tight, right? But I mean, as a designer, it's always best to use your discretion, right? It's always best to use your discretion, right? Because there's always a lot of different arrangements that can be used, but you pick the one that is best, most efficient, and most convenient too, right? This could have gone out here. Remember that for this our project, we allow the pipes to go out, right, into the pipes to go out into the outside the building, right? It's not within, not running within these walls. And this was partly because this room is kind of room that the walls are insulated. This is a cold room, so I wanted to reduce how much I tamper with this wall as possible, right? So luckily, because the pipes are way bigger. Wait, I use CWK. This shouldn't be CW, it should be SS, standing for sewage. SS, not CW. So correct that, right? So I mean, unlike, because if it's fresh water supply, the pipes are way smaller, half 3/4 of an inch, so it's easier for them to get frozen. But in this case, it's not so easy, because one, the pipes are bigger, and two, the pipes are not always completely full. They are meant to be flowing at maybe about half the volume of the cross section, right? So freezing is not usually a high concern here, right? So these are just all things you put into consideration when selecting your routing, right? This looks like it's going to be tough for the what is his name, contractor on site to work with, right? So I might have to change the route a little, right? Obviously, to still pass, let's use this. Okay, I'm going to, okay, let me delete that first. I want to add something like this. This is just something that you just discover maybe along the line in your design, discover that this design doesn't work or it's not the best. So you now make changes, right? So you're copying this to somewhere here. Okay, this should be on. Okay, now if I hover over it, it comes up. Okay, right. Now you ask yourself, is this design better? If it is not, you try another style too. Now this is going to take up more pipes, right? And then you can still vent it at this point too. Okay, so let me add something here. Copy it. Now you see that this alone has made me add another pipe, vertical pipe for venting, and has made me add extra pipe. So these are the questions you ask yourself: is this design worth it? Is it economic? Because economic means using the least amount of items, but it also needs to be optimal so that you don't save materials at the cost of efficiency, right? So you ask yourself if it is worth it for design to be like this, right? So there'll be two pipes traveling beside each other, right? So that's why I selected that former method. Control Z. So I selected this. I mean, this might look tight on site, right? I mean, that is something I'm having in mind, but if it is approved, then I mean it can work. And of course, a contractor on site has a freedom to an extent to make some little changes that is going to suit him better, right? So let's just leave it the way it is. And then these two could have also, another route would have been if it went out here and connected to this place, right? But this is a window. This is why when you are designing, you have to align with your architect. If you are working on a project where you know the architect working on the building, right? So these are like some things you consider like in that pre-design stage where you reach out to the architect to make some changes. An architect may not know that placing a sink directly in front of a window is a problem. Okay, it's not really a problem, but it is a bit tricky to vent because vent usually goes up, is a vertical line, right? So I mean, you now that the design plumbing designer now can decide that okay to go there, but it won't get to the window. You just travel up a little and then it can continue in the wall. So these are those different design concepts or different design ideas you can like implement, right? And this wouldn't have worked, but because this cabinet is here, so it covers all this space, right? So if I want my pipe to go under here, it works too. If this was an open space, it won't make sense that this sink is going to drop into the ground. It will just be visible, right? But there's like a plumbing cabinet around here that covers all of that, right? And also, again, if the contractor on site thinks it's better to route it this way, he might do so, right? So I'm just telling you the pros and cons of choosing which things you put into consideration, right? So it's nothing is set in stone. You select the most intelligent part, right? So let's check what else. Okay, DFUs. Let's put our DFUs. Right. So I think I've already done that. Right. Which page? Okay, this is it. I already arranged some of the things. Okay, I remember what I talked about SS standing for sewage. Right. Okay. So we've already, based on the available fixtures on plan, check this building is in Florida. Right. So we use Florida code. Right. And then these are all the fixtures on plan and their quantities. Then the DFA. We've read these values before from this table. Just search this table and read these values from there. And the total based on the number, the quantity, and then the minimum trap size, right? So let's just quickly let's see how many minutes we've spent so that we'll know whether we'll look into this. Okay, this is the table I'm speaking about. So FPC, so you read out your fixture units here and then the minimum trap size here too, right? So moving on, let's go back to our design. Well, let's go back to, yes, this. So we lay out our gravity piping proper stoop. We've already done that. Size sanitary pipes using is, now let's size the pipes DFU. So that's why we needed to get this total DFUs. So let's get the total, which is 14. So now we go to our table. Which table is that again? So I mean, in most cases, we use a minimum of 3 inches, right? So this is the table we are using, right? So in most cases, as far as you have a WC on plan, I mean 14, our DF was 14, so it's somewhere here, right? For this, so that is minimum of 2 normally, but because we have a WC on plan and WC takes up, has a fixture of the minimum trap size of 3, right? Where's that WC? Right, so not D of 3. This is it here, right? So that just basically means that once you have a WC on plan, just use a minimum size of minimum pipe size of 3, right? So let's just add that to our plan. So this is the main line. So just litter this, just add it on plan so that it is easier to, okay, added it now. So this shows that this line is 3 inches and then this main line is 3 inches. So what's next on our list? Right, is it this enters into the ground? Right. Okay, so next is to check code limits. I mean, this is already part of your notes on plan, right? Design vent. Okay, let's talk about the venting of this project, right? So make sure you vent every, you've spoken about it already, Sha. So the venting line goes up here, and then this one goes up here, and then somewhere within the ceiling, right, they meet. And then, okay, let me even add that just for better understanding, right? So the line, it could either travel along the same distance, but or you could just travel in the shortest distance to meet this point. So basically, this is just so that this creates a kind of circuit vent, right? So this one comes up here, and then this one that is entering the roof, when it penetrating the roof, is like the main vent stack for this. Okay, these two, because this is why I made the line to run here. So this just drops directly into it on the ground. So this vents this as well as this, right? So 1, 2, 3, 4, and you see that I place this closest to the WC, right, for better efficiency. So all of these now are in a circuit, a venting circuit, right, that is vented up into the roof at this point. Okay, and then these ones serve, the reason why we don't have so many of these, you can't imagine putting one of these at every fixture. It's going to be so many penetrations in the roof, right? So this is vented here, this is vented here, and then it travels in that vertical vent line. You can't see it because this line is behind it, but you'll see it better when I show you the riser diagram, right? So this comes up here. So okay, this one I can be seen here. So I mean, vent lines don't need to have that 40 degrees or 45 degrees bend. So this one just comes straight into this point, right? So okay, so this is what the vent looks like. Let's complete it. So all those vertical lines arose from each of them. This is the lavatory. This is above ground level, the WC. Then that shower we spoke about. This is, the showers use the floor drain, so it's not like a bath. Bathtub has a different type of. See, this is floor drain. right? Bathtub has a different um, drainage trap, right? So that's just a slight difference, although they're both 2 inches sharp. But let's just do that real quick. Vent. So we draw this up here. Okay, this has turned off again. Okay, and then okay, and then connect it here. And remember that this one that is going from that WC is serving all of this, right? And then these ones too, they are all going to be connected in a circuit type of system, right? Because there's no way we are going to okay. There's no way we are going to give all of them individual okay events, right? I mean we could do that, but it's not very advisable. Okay, oh, I should have copied that. Okay, I can just complete it from here. Okay. Then I have another line going up from this lavatory. So this is just a way to show that okay. It's just a way to show that they are all on a straight line or they are all vented properly, right? So anything within here, there's a loop or a circuit in this place such that everything, all these pipes, right, they are all connected to these vertical pipes that are allowing air to escape through them until they meet this point and then leave through here, right? So let's go to this. Now this is what our vent looks like displayed on our sheet, right? So now you can take a look at this is the plumbing riser, the freshwater supply, right? So now what next? Select equipment. So let's look at what are the equipment that are needed for this project, right? Let's look. Normally the available equipment are usually um either okay, this is the section, either pump or grease interceptor. Well, none of that in this case, but there's a sewage, there's a septic tank, right? And I went and checked and added notes here on how septic tanks are sized, right? So size the septic tank, you need to find this table in this IPSDC. This is a code, and then that will enable you to size it. It sizes based on the number of occupants in that building for a private building, right? So let's look for that code. Yeah, so this is that code we are looking for. This is that table, and this is just basically sizing. This is a different code. This is the International Private Sewage Disposal Code. I have not checked for Florida, but I'm sure Florida has its own copy. And most of these things don't always vary too much, right? So number of bedrooms. Our building has 2 bedrooms, so we're going to use a 750-gallon septic tank, right? So our building has just 2 gallons. Let's look at it. 2 bedrooms rather. Okay. 2 bedrooms, which is this master bedroom and this other bedroom. So 750 works. So that's why this is 750, right? So what else? Nothing much to be looked at here. Okay, this is where I spoke about those keynotes on plan, right? So the reason why I use keynotes is because I didn't want to have too much clutter. Imagine writing out this thing for this sentence or this vent stack for every time it occurs. There will be so much information, so much clutter to deal with. So this is 3-inch sewer line. This is 2-inch sewer line. This 3-inch is usually for WCs, and this 2-inch is for sinks and other ones that the trap are not usually so large. They are not expected to allow for too much um flow out at once, and they also don't permit solid waste out of them or through them, right? So you see that this is for this, right? So what else? Okay, coordinate with. So this is where you send in there's something they call building information management. So this is where you check that all your designs align, and if your design clashes with either architectural or structural, you would have to make changes, right? Oh, this is not necessary. Okay, this is not even necessary. This is when I was doing my research, right? This is not necessary. although it's still a rule of thumb, sure. This is a rule of thumb, but it's always better to go by the code. Rule of thumb applies when you don't have the code, but the code is the standard. So let's quickly go on to designing something else, which is the another project, right? So okay, so this is our winery and production building, right, with our mezzanine large building. So let's do the sewage plan for this building, right? So let's go to okay. Let's do sewage. I have a layer for almost everything I need. Okay, where I set my line type and thickness, line width rather. So now I remember saying that flood drains are usually placed in rooms where there's likely to be a leakage, right? Or there's likely to be an overflow or spillage or something of that nature. Right, so this is a storage or production space, right? And these are actually barrels, right? So there's every tendency for this entire space may not be full, but at least to a significant level to be aligned. This is like a warehouse kind of. It's like a warehouse, a storage, a production, winery, all together in this space, right? So there's likely to be leakages in a lot of places. I'm going to add flood drains to a lot of places, right? Then what else are we doing in this project, right? So there's only one bathroom, so it shouldn't take time. And then there is this sink in the on the mezzanine floor. So let's, without further ado, and then we also have this. We've not know what this is, but we'll talk about it today. This is a drain, a long horizontal drain, or this entire thing is a drain, and it also helps to manage for that leakage, that spillage happening around. But it's still just good to assist it with like some little drains on the sides, which I'm going to do, right? By my own discretion, no, right? So let's just add that. So I'm going to add one here. So there will be something going from here. Okay. Into the wall, right? Okay, I don't want it to be in the wall. I try to avoid walls as much as possible. I'll take it to pass outside, right? The only thing that this is just my own personal preference. The only thing I'm comfortable with passing in the wall is freshwater lines. But these drainage lines, unless I don't have a choice, I like to pass it like I would have passed it within this space, but it defeats the purpose of that my reason of not wanting to pass it within an interior space where if there's a leakage, it's going to be a problem, as I'm taking it out entirely, right? So I mean, the only problem we have to deal with here is it getting frozen, which is unlikely, right? So we go up, right? So okay, somewhere here, somewhere here, okay. Then just out like this. Remember, at every turn there's this, right? So we're going to have another. So we had one here. We have another one here. I mean, I can just copy it and move there. This needs to be joined. Okay. Okay. Just copy this because they're all going to look alike. So add it somewhere here. Right. Then so I'll also add another one somewhere here too. Because this is a really large space. Somewhere Because I mean, can never know for sure. It's better safe than sorry, right? So I'll do that for this other side as well. Just add one here, somewhere here. Okay, straight up. Outside as well. Now, if I want to put my clean out, it's not going to be a problem, right? Right. If you have to make any discretion, personal decision to make any um changes or any decisions, make sure you have a valid reason. My reason for wanting to run pipes outside the wall is because I don't want like putting clean out to be a problem, right? But there are some cases where it may not be the best option. So it's good to have a valid reason so that if that reason doesn't apply anymore, you can make your changes, right? So you don't just copy me or cram what I'm doing, right? So I'm going to also add a, this will be the main drainage, so okay, a line. I'll add, there will be a point where it comes out here, and then I'm going to add a pump because this drainage is definitely okay. I can just do that. It's definitely okay. Let me show you another little trick in Revit. So I can decide how I want the circle to be. So this is the one I'm using, but I want to use maybe this. It is not going to draw directly from the ray from the center of the circle, right? So this is going to be my pump. Right? So it's going to take it up out of the ground because what is draining out of this building is actually useful. It's not like sewage. It's just a way to drain out if maybe the wine or the grape juice or whatever is here spills. So there'll be a need to like take it out and then treat it or something. Right? So it's not going to like go directly into the sewage line, right? So something like this. And then I want it to go in different direction entirely because it's not part of our sewage, but it's still part of like a drainage plan, right? So and then we add, okay, somewhere here. There's a storage tank here, somewhere here. And thankfully, I'm not the one that has to size it. It's going to be sized by someone else because they have like some engineers on plan that all I have to do is just to show him where it's going to be, and then he'll be the one to run the remaining. Right, so this is the tank, and then there's after this it also still goes out to the city, right? Like after the treatment that's taking place, whatever is now supposed to be disposed of is disposed of that way. Now what else? Let's go back to our this thing. So assign DFUs. Let's do that. I mean, I've already done that to save time, but let's just look at it. Oh, I'm not done. No. I forgot that there's a bathroom here. Let's do that quickly. So we have this. Okay. This. Right. So and then goes out through here. Right. I mean, and then goes out and meets this guy. So we now have this guy too going out to meet those guys. So right. Okay. So I'm just going to trim this. Okay. What else? What else? Okay, we also have our sink from this floor, this mezzanine floor, right? So just going to pass outside. If you remember, we had to deal with passing the freshwater lines right here, and I made them. A little thing I just did was to make them to run on the inside, so we can avoid the issue of freezing. So then this one runs on the outside, being that they are going to be running beside each other. There's likely to be a clash, so I'm going to make it such that it runs on the outside, and then somewhere here closer to the outside, since it has lower chances of freezing, right? I mean, it could still freeze, but so somewhere here is where it's going to drop into this place. So that floor now is going to drop its own line into down somewhere here, and then that is going to connect to the existing system down. So you're going to drop somewhere here, but we'll check that soon. So what do we have on plan? We have a WC, a sink, sorry, a lavatory, right? And then a sink. And then we have these several floor drains scattered across, right? That are making up this. So this is our DFU table, right? So we have our available 5 floor drains separate from that long drain, that linear drain. Then we have the DFU factors and then the total, and then this. So now we have a minimum of 17. This 17 is quite close to what we had for this other project, right? 17. So we just know that 3 inch is going to work, right? So that means our pipe is going to be 3 inches. Now let's complete that. Let's just add all the necessary details, and now it looks like this, right? So we've added our clean out here, so you see that it is not in the direction, it doesn't affect, it is opposite the direction of flow. It goes this way, then the clean out is out here, right? Then we have our, I mean, this could have been 2, but just leave it at 3, being that it is outside, it could get frozen. 3 is just a safe value. So we have floor drains all around here too. And what else? Okay, yeah, this is our sump pump. This form means something. We'll look at that on our sheet, right? So this is another clean out here because it's a change in direction. If you notice, this is a large reading, so these runs are going to be very long, could even get up to 100 feet. Let's check what's the distance of this, right? It's going to be quite long. So see, it's almost up to 100. So I mean, fair point. I mean, there are buildings, larger buildings, where it could be way more. So that's where the clean out comes in, right? So use your discretion to add it. Now this storage tank, I'm not the one sizing it, thankfully, right? But I'm sure if you do a bit of research on either international plumbing codes or this is a California project, you'll be able to find something that can enable you to understand how this sizing takes place, right? And now this is just a bit of a clash. So this just shows that they are not clashing. So one is passing differently from the other, either above or below it, right? And we have this is also vented, right? So any of this, any organic kind of activity produces gases that need to be vented, right? So this is the vent here, and this is the venting of this system, right? So we have this. I mean, this could have easily passed this place, but I just drew it here to indicate that there's a vertical line coming up here, and then the horizontally it travels within the ceiling to this point, right? So this is where that line from the mezzanine floor drops into this point. If you notice, it corresponds. Now let me show you how to confirm that this corresponds on plan. Right, these are little things that makes your plan to be more efficient, right? So let me copy it. So I'll look for a point on the building that is commoner for the both buildings, for the both floors, right? So let's use that point and copy it here. So it comes and stops here. So that point is going to land at the point that is going to be on, right? So when we do that, so that it landed somewhere here, right? And this is now vented at this point, right? Okay. I did not add that vertical pipe, right? Again, my discretion, but this is um the only I mean, I should standard by standard. I should let me add it. This is what I'm referring to. This I should I should right. So this needs it. This needs it. It's basically, even though it doesn't extend to the roof, it's just a place like a pipe for the air, the gas to travel up out of. It helps to prevent gas buildup, which can cause problems, right? So add this here. Okay. Okay. I mean, I think I'm getting some distraction there. So yeah, that's just basically what it is. So then we have our vent line going to this point, right? Why I didn't add it is because there's just one fixture here which is not like in constant use. So the gas demand is not going to be so high. So I mean within that it's going to like the wet vent of this place still works, right? But let's just to be on the safe side, right? It's better to overdo than to underdo. So what else? What else are we put into consideration? Let's look at our list. Okay, we've done this, we've laid out the lines, we've done we've sized the pipes because it's minimum of 3 inches. Once there's a WC on plan 3 inches, then it increases when there's like more fixtures, and that results in like a higher DFU total, right? And then design the venting and traps, we've done that. Okay, to protect traps, we've done that. Codes on trap arms and this, right? That is on plan. Then that is on notes. Then select equipment. What do we need? Okay, the pumps. Okay, now I didn't really talk about sizing an interceptor. I've spoken about it before, but let's just see if we can like do it on this project, right? Now, this is not a kitchen, so grease is not likely to be formed here, but we can just add a grease interceptor, right? Where should we add it? Now you see that routing is in outside is a problem because most time grease interceptor is added at the point where it is at the point P. It's usually added along the line, right? And it could be added here, but that is not advisable. And another thing with grease interceptor, it shouldn't don't add it the flow from a bathroom and a lot of other any place that will contaminate that grease should not be part of the connection, right? If I was going to add a grease interceptor here, because this connects here, I would have added it here, but because this is going to flow into it, I'm not going to add it there. So that will mean adding one somewhere here because it covers for all these, right? And one here, right? Although this project doesn't really have like a high demand for grease or high supply of grease, but I mean that's just what it would have looked like. I spoke about when I designed this project, right? So going by trap size, each floor drain has a trap size of 2 inches, right? Just like a regular kitchen sink or many types of sink, right? Sinks, right? So there are 5 of them. Now that means this is the value, and then this is it's going to be a 25 GPM flow rate interceptor, which happens to be this guy, right? So now it may be like a bit of an oversizing because those floor drains are likely to not be used much, and even when they are in use, the grease is going to be next to nothing. So by my discretion, I'm going to add it here. But if I had to, if this was a kitchen sink, for example, where there's a lot of grease going out of, I would have added it like I mentioned, right? And then I would have indicated on plan. Another thing we have on plan, that equipment we have on plan is a pump, right? So this is um, we used, okay, this 4, and then this is the line going out of it. Now, based on the size of this linear drain, I was able to ascertain that we're going to need a drain line of, observe how it's drain line, not SS. A drain line, this is SS, a drain line of 6 inches, right, in diameter, to, because the design is for in case this whole place gets overflow, like if the spill fills up this place and they need to drain it out, right? So we size for that, right? So a 6 inch was able to handle that. And then you also needed a pump that can handle it. I mentioned pump one time, how pumps are sized or how they are selected. So it's important to select a pump that can handle solid, right? Because it's pumping from down to a height and then horizontally. So this was the pump. Okay, this was where I sized the pump. So this is the expected GPM, right? I mean, this is not part of like our regular design. This is just something I did on my own discretion. And then I selected a pump that can handle up to 600 GPM at 10 feet. This 10 feet means at a feet of 10, at the height of 10 feet, right? And then it can handle solids up to this. So I checked through the specs and so that it can handle solids. So this pump now is going to be very durable, very capable, that's the word, of handling a lot of cases. So if it's a high flow, it can handle it. If it's a flow that has solids, it can handle it, right? And being that this is a commercial building, so I mean for residential, it would have been way less, right? And then temperature too, you can handle fluids at as high as this, right? So what else are we looking at? Okay, okay, this is okay. Okay, now coordinates. So okay, now lest I forget again, let's look at the riser diagram for this project. Now, this is the riser diagram. You see how it looks a bit complex. This is the riser diagram for because it is not a one floor building, right? So you see our 5 floor drains at the farthest point away from the exit point, and then our bathroom, which consists of the lavatory and WC vented accordingly, right? And then you have this going out here to the sewer, the city sewer, and then this is a storage tank which we did not size, so you don't have to worry about the sizing, right? With the size of the pipe, and then that floor drain we saw that leads to this, that linear floor drain, right? And now you see that they are all properly vented, right? Okay, let me add something here. So I mean, for each of these floor drains, I could have done this for them, but I did not do it. My own discretion again, because they're not going to be so much in use, and I don't imagine running vent pipes like are high above those spaces, right? But then again, against my personal wish, just so that I can follow standards, I'm going to add it, right? I'm going to add it. It's better the plan states it, and then for some reason, okay, okay. So now this just basically means that these two, okay, this one, okay, these two are served by this one that's going up into the roof, and then extend somewhere here, right? And then we have another, okay. Now we do this again. We have another that is for these guys, okay. So we are still okay. We are not on our vent line. Let's go to our vent. Okay, layer. So now every line we draw will look like a vent line. Okay. So this is now what it looks like, right? Okay. And then I extend this one with shift key. Extend it again. Good. Now to be on the safe side. Now this is going to mean that there is vertical pipes running, and so the vertical pipe goes up to any distance of the contractor's choosing, and then there's a vertical pipe connecting them for more efficient venting, right? So good there. Now this is works, and if you notice the vent line, that the vent penetration that passes here continues through this floor. This is all within the wall into the roof, right? Because there's no roof here and it's not advised. You can't vent it and then leave it to be hovering within, or yes, within the building, under the building, the roof. So it has to go up into the roof and then before it is vented properly, right? So that is that. That is that. Are we missing anything? No, we are not. I think we have come to the end of today's class, and if you have any questions, shoot to me. Now I would like you to go and do your personal research and try your hands on different projects too, to see how much you know, because if you think you know enough, there's a lot of project that's going to surprise you, right? There's always something new when you like get your hands on a project, right? Thank you for showing up.